With what seems to be the end of the crypto winter, there's going to be a lot of large opportunities for developers to take advantage of. My prediction is in the coming future, we're going to see a much larger demand for blockchain developers. But the big question is, how do you take advantage of one of these opportunities? First, you have to learn the skills and the basics in order to master the Solidity programming language. In order to do so, you have to master a few smart contracts and develop them on your own. In today's video, we're going to be going over the Vault smart contract and how to actually write one from scratch. My name's Anthony with the Blockchain Dojo, where we turn you into a blockchain ninja and a Solidity expert. If you learned something new, please like and subscribe for more content. Let's get started. In order to get started with the smart contract, the first thing that we need to do is actually add in the license identifier, the Pragma version, as well as you want to import the ERC20 interface from OpenZeppelin. Next, what we want to do is declare the Vault contract, and then the first variable that we want to declare is address public owner. So in this address, this is where the owner address will actually be stored. Next, what I like to do is add the constructor and then initialize that owner is equal to msg.sender. Next, what we want to do is add in mappings, and this mapping is going to map the address of the ERC20 token to the amount, public, and then we're going to do token balances. So what this does is it takes in the address as the key and the amount of tokens stored as the value. Next, what we want to do is create an array of addresses, and this will be the stored token addresses, where we keep track of all the tokens stored for the key to reference for the keys in the token balances. From here, we want to enter in our receive functions as well as our fallback functions. Now the fallback function, the only difference I'm going to make here is I'm going to put a revert. And I'm doing this specifically so in case someone tries to make a contract call to this smart contract that doesn't exist, it's just going to revert. It's just an implementation for security purposes. Okay, from here, we want to enter in our store tokens function. Function, store tokens, which takes in an address of token and a uint amount. This will be a public function. And the first thing we want to do in this function is we want to check that the token balance is the same as the token passed in. So if the balances of the token passed in is equal to 0, what we're going to do is we're going to store the address of that token in our array of stored token addresses. Next, what we want to do is we want to increment the token balances of the token contract by the amount. Then what we want to do is ERC20 of token dot transfer. First we got to do dot approve, and we're going to approve address this and the amount, and then ERC20 of token dot transfer from. We're going to transfer from msg.sender to address this, and we're going to transfer the amount. And that is a quick store tokens function where you're able to actually store the token based on the address and the amount. We're checking to see if the token balance is 0. And if it is 0, we will store the token address in the stored token address here. Then we're going to increment the token balances of this token address by the amount. Then we're going to approve that this contract is able to transfer tokens from the message.sender to this address and then to the amount. Okay, so up next, what we want to do is write a function to withdraw ether. And what this is a public function, and we want to make sure that the only person who can call it is the owner. So we want to do require owner equals msg.sender, only owner. I'm going to cap that off. Next, what we want to do is we want to ensure that the balance of this address, the ether balance of this address, that is going to be greater than 0. No ether. All right, and then from here, what we want to do next is we want to actually make a call to the owner address and transfer out the ether. So in order to do that, we want to declare a bool for success, and we can return the call data that is returned. We want to equal that to owner.call value of address this dot balance, and then the function data that we want to pass through will be an empty string. Cap that off, and then finally what we want to do is we want to require that the returned Boolean success is in fact returned true, else transfer failed. Next, what we want to do is we want to make a withdraw token function, address, token address, public. And then first thing what we want to do is we want to require that the message.sender is equal to the owner, just to ensure that there is no access control vulnerabilities. Then we want to require that the token balances of token address is greater than 0, else there's insufficient funds for the transfer. From here, what we want to do is we want to declare a local variable for the transfer amount, uint transfer amount, and we're going to set this to be token balances of token address. From here, what we want to do is we want to set the token balances of token address to 0. That way, in case a contract calls back into this, we can avoid any potential reentrancy issues. Then from here, what we want to do is we're going to create a for loop that will loop over the stored token addresses and then remove out the token address that we are withdrawing at the moment. So for that, we do uint I equals 0, I is less than stored token address dot length. Then we increment I by 1. And then if the stored token addresses of I is equal to the token address passed in, we're going to delete the stored token address. And then finally for this function, what we're going to do is make an IERC20 call to the token address, and then we're going to transfer to MSG. Actually, we're going to transfer to owner, and then we're going to transfer the transfer amount, which is locally stored here. And then finally, I wanted to include 2 helper functions here. These 2 helper functions will return all of the tokens or the array of token addresses, as well as the balance of this contract.